Thank you so much and good afternoon. So today I'm representing the group on Earth observations in addition to my University of Maryland affiliation. So group on Earth observations, just very briefly what it is. It's an intergovernmental partnership. It's kind of an IPCC for Earth observations. So we bring together stakeholders to understand the needs and to promote the use of geospatial observations and Earth observations specifically. As you can see on the graph on your right, the mission has been transforming from just kind of bringing the Earth observations into the broad use data for all motto from the 2005 to 2015, we're currently transferred to the Services for All agenda, and we're looking forward to starting the Earth Intelligence for All phase, starting roughly in the 2025. There's a lot more information about all those components on the website, which I encourage you to see. The GEO solutions are focused on a broad range of issues, with public health being only one component among those. And in that public health agenda, the Earth Observations for Health, EO4Health, coincidentally, is co-chaired by two prominent scientists. One from NASA is John Haynes and Julie Trunch from NOAA. And it is effectively coordinated by Helena Chapman, also at NASA, who I believe is probably logged into the system right now and listening to this presentation. This approach is also very firmly rooted into the One Health approach and is looking at bringing the Earth observations to support understanding of dynamic ecosystem processes and how they influence human and animal health. Now, within the community of practice, we have 5 individual work groups, and this is where I come in. I represent the environmentally sensitive infectious diseases, which is a work group that I co-chair together with Antar Jutla at the University of Florida. And we are organizing the community of practice, the practitioners, and the scientists from around the world. It's really truly a global community to look at improving prediction and prevention systems for environmentally sensitive infectious diseases. And that involves both vector-borne and waterborne and even airborne. So just an example of what the Earth observation data use can be, I'm going to give an example of my own work that's focused on assessing environmental change to the global malaria echo niche. So malaria is reportedly the deadliest event for humanity over the entire course of the life of humanity, right? Killed more people than anything else. And unfortunately, the recent news is extremely disturbing as malaria appears to be on the rise globally, in Africa, in Asia, in South America again. So in fact, to the point that we are at this point about 55% off track from the milestone for malaria elimination where we were supposed to be. Very disturbing, very sad news. It's best been summarized by Nora and Alonso in the 2022 Lancet paper. And what they said is that, yes, the progress that we've had, and it's been tremendous, has stalled and has reversed back. And the reasons are complex. One of the reasons, however, that is not mentioned, that I would very much like to highlight, is the potential for the global environmental change. The efforts that have been in place have been fantastically successful, but the playing field has been changing quite rapidly as well. We know that the temperatures have changed, the precipitation abundance and regimes have changed. We know that the vegetation and the capacity to hold the moisture on the landscape has changed. And the human modification of the landscape has been one of the most rapid changes that brought people into the diseases area, and they actually amplified the potential for transmission quite substantially. So in this particular study, we looked to answer two questions. What malaria-affected regions have experienced the greatest change in environmental conditions that could enhance malaria potential, and where the malaria-affected regions have changed towards inhibiting malaria potential? That's what we're calling malaria echo niche, where it can be. So malaria lies at this intersection of parasite, vector, and the host, and we know that different environmental factors really impact all of those. We know that the temperature impacts both the parasites and the vectors in different ways, albeit. The precipitation is very confusing because case studies reporting drastically different results, but we do understand that biophysically, precipitation, how fast it comes down, impacts the vectors, but it also impacts the vegetation and the landscape moisture holding capacity. And as I mentioned, land cover and land use change has really introduced the hosts, us humans, into the areas where malaria previously wasn't an issue, and it keeps introducing different subpopulations of parasites into the areas where the local people do not have any resistance to it. So just very quickly, to understand how the conditions have changed, we transformed the actual measurements, the observations, into the malaria relative metrics. In this case, it's the number of optimal temperature days. And then we look at the 20-year trend in those estimates. And this map shows you the 20-year trend of significant change. And you can see there's a quite number of places, particularly India, Pakistan, East Africa, Southwest Africa, where the temperature has been going up quite, temperature suitability has been improving. Precipitation is more challenging. It's always been more confusing, but again, we see some areas where there's substantial growth in better conditions. Vegetation has been changing quite dramatically. And again, if you want to keep an eye on the Western India, Pakistan area, that's one to watch. People have been modifying in malaria relevance, it's cropland expansion and managed forest that are of particular interest. So one of the challenges is we don't really have a good handle on how they interact. So we implore fuzzy math to help us understand that relationship. And what it gives us is the range of scenarios from the best case for us scenario to the worst case at the bottom. And this shows the change in optimal moisture conditions, in climatic suitability, and you can see interpretation can vary quite substantially. And if we incorporate land use exposure into this, it will add certain areas where it's particularly enhancing. So bringing climatic suitability with land use exposure together, we're looking at the total change in malaria echo niche. And as you can see, on average, the conditions globally have drastically improved to support malaria propagation. If we look at specific hotspots, Brazil, Argentina, Uruguay, Paraguay stand out there. We have the East Africa, and we definitely have the India, Southeast Asia. There are a lot of uncertainty in other areas, particularly in sub-Saharan Africa. And the only thing I have to finish with is that global environmental conditions supporting malaria are improving. We desperately need more research to understand how these components impact our ability to eliminate malaria. And it's really that Earth observations enable continuous monitoring of the dynamic environmental conditions and really should be considered a critical asset. Thank you.